Hello guys, welcome to next video of in the series of the art of computer programming. Today we're gonna discuss about the next topic, which is mix. Now if you move on to the maybe next section in the art of computer programming book, you're gonna see this term highlighted, like what is mix, and basically the first question that comes to mind is what is this mix, where does this come from? So this mix is basically a computer architecture. It's not any computer or any operating system, it's a computer architecture, how the computer chips uh, work at the lowest level of the abstraction. So what is mix? The first question is, it's a computer architecture. It's a computer architecture. Now the second thing is why we are using mix. What does the purpose of mix? Like when Donald Knuth started writing the first volume of the art of computer programming, this is the computer architecture that is used by most of big companies like IBM or Intel, or even IBM and Intel and other big companies like Microsoft, and they are all using this computer architecture. That's why Donald Knuth thought that all the people are talking about mix, are talking about our computer architecture. Let's come to a conclusion that we're gonna think. We're gonna imagine. This is only imaginary term. This is not a real term, because at that time there were not like many copyrights kind of issues. So that's why different companies put different names for their computer architecture. But Donald Knuth was writing a journal book about this, so he thought that mix will be an imaginary computer architecture which will be having characteristics of almost of each and every operating system that was the operating systems architecture that was used back then by IBM or Intel. So this is imaginary. This is an imaginary computer architecture. So let's move on, or move further ahead and discuss about what's inside this mixed computer architecture. What are the things, how the different components on a computer chip, like suppose this is our computer chip, and how the different components are distributed on it. So for that, let's say here we have our memory, okay, and here we have our processor. There are a lot of other stuff as well on the computer chip, but we will be having a look on two things only. The processor, we're gonna say it P just for simplicity, and our memory, that is M. So here we have our processor P, here we have our memory M. Now let's discuss further, like what's inside P, what kind of registers are in P, what inside M, how the memory is divided into different sections, or we should say parts or arrays or whatever, in this mixed operating system. So firstly we're going to discuss about the P, that is the processor, that how many registers our processor have, and how this our processor fetch the instructions from the memory to execute any program. So basically in our program, how the instructions are fetched and everything. So let's discuss about processor first. Our processor have like a number of registers are there. First is the register A, second is the register X. So let's see, I just gonna draw these. Let me draw this stuff first, then we're gonna discuss about it. So there is register A, register X, and here we have A1, A2, A3, A4 and A5, and in our register X we have this one, coming down here, we have x1, x2, x3, x4 and x5 with a plus minus sign. And there are other registers as well. There are almost 7 other registers as well. 6 of these are called I registers and one is called J register, which we will be discussing further on. Like we're gonna deep dive into these registers, and I will also be putting some images of the architecture, complete architecture, so that you better understand. But the most important is these two things in our processor to be understand, like what are these stuff in our processor. Because the I registers are same, but they are only this much. So if what is an I register? This is the I register. If you simply say with a different name and a number on it, these are our I registers in our processor, which are 6 in number: I1, I2, I3, I4 and I5, I6. But these two are main because these directly fetch the instruction from our memory and put it here. Now let's discuss about what does the plus minus mean. And as you know, like in computer, like how does computers store the negative and positive numbers? This is for that purpose. But nowadays, if you look at other architectures like Intel architecture nowadays, they say it's either 0 or 1. But at the time, plus minus is used just for explaining in an academic environment. So our A1 is a byte. A2 is also a byte, A3, A4, A5. So these are our bytes of data which is fetched from the memory. Now let's discuss about the memory. Now this is the only thing that we need from the processor point of view, that there are, keep in mind that there are something called register in our processor, which are of two types, A and X, and there are other registers as well, which are called I registers: I1, I2, I3, I4 and I5 and I6. And there is other register, one other one, sorry, it's too much, J. Let's now put some information about memory, M. So here we have our memory, that is M. In our memory we store 6 like this. So in our memory we store data in 6 bytes. So this is 1 byte, 2nd byte, 3rd byte, 4th byte, 5th byte, 6th byte. So this is our memory. In memory the data is stored like this. Now the key thing that is point to be noting is that this first byte represent the location of this much data in the memory. What is this? We can say that this is the key to open this door. Okay, if we want to access this data in our program, we can say that here we can feed in our instruction that go to this location in memory and grab this one. Okay, now this much data will go where when we grab? It will go to our processor. So the processor will put it here, A1, A2, A3. This byte will go here, this, and this sign will be if it's positive number or negative, accordingly it will be represented here. And then in our processor we can execute any kind of like plus, minus, or any kind of mathematical operation on this data. And when we are done, we will be storing back these data. Now we can store back this data back over here in the same memory cells. But if we want to store it to another memory cell, then in our program we need to mention the location of new memory cells that will be used. Like if we want to store our data here, then in our program we need to say an instruction. We need to give an instruction that save this data at some location which is denoted by this number, and our data will be stored over here, whatever the data will be. So this is the basic information about mixed computer architecture, how it works, how the processor, what's inside processor, what are the registers, and in our memory, how the memory cells are divided, and how we can access the data from the memory. In the next videos, I will be discussing more about these, the computer architecture, and also we will be discussing about the different operations that we can perform on data and manipulate the data, add the data, subtract, and other things at very low level. It's not like a C language where we it's not like C programming language where we just say that uh, let me just provide an idea about where we are coming from. So like in C programming language, which is of course the programming language used by Donald Knuth. So C programming language, we say that, I'm just talking about the basic things, that in order to add two integers, we say int a, int b. We just give these two instructions. Whatever, there is some stuff over here, whatever here, we don't care. We say int c, and then we say that c equal a plus b. So this means that in our at very high level of abstraction, we are defining two integers, that is a and b. Then we are adding it and we are storing it in it at some variable c. So we will be discussing how this code will be executed at P, processor, and M, memory level. So this will be low level abstraction. We will be discussing this as well, so that we can develop very good understanding of the programming concepts, that how the high level languages convert to the low level stuff and talk with the hardware and made the hardware to do certain things. So for now, that's it. Thank you for watching and stay tuned for the next video. Till then, goodbye.